My name is David. I am one of the founders of the Arduino platform. I have to say I'm really, really honored to get this prize. To me, it's a recognition to many years of work. The platform was created 10 years ago, but it's based on a lot of work made before that. I'm also an assistant professor or adjunct at Malmo University, which sounds a lot better in English than in Swedish, which is Malmo Högskola, which is not really university, as you know. But we will make it there. There will be enough PhDs very soon. And I'm one of the researchers in the Internet of Things and People research group. So that's a bit about myself, as well as I really like to write about very obscure subjects, like how to build physical accessories for Android devices or how to program wearable Android devices. I'm an educated microelectronics engineer, and I worked before as a project manager at a radio company in Spain, as well as a microelectronics engineer at Infineon Semiconductors in Germany, before I moved to Sweden to teach at an art school. So you get a picture of the person you have in front. Well, the thing is, I teach artists and designers how to use electronics in their everyday practice. And the reason for this is that more and more of our lives are becoming digitized. More and more of the things we do are basically based on digital electronics. And I noticed a tendency around 2002 that there was more and more of a disconnect between what designers were trying to do and what was inside the objects. And at the time I was teaching design students how to program Java. You can imagine how challenging that can actually be sometimes. So I thought, what if these people that will become the industrial designers of the future had to understand how devices will behave in the future? So I came with to the idea of like, we need to teach them how to build state machines. We need to teach them how to make things that can react to certain stimuli. They need to learn about sensor technology. They need to learn about actuators, about motors, and so on. Of course, not how to make a motor, but just how a motor could be used in practice. So I came with the idea of making something like this, which was a circuit board that my design students would put together by themselves. It would take them about 12 hours because most of them had never soldered in their lives. And the question is, what could they achieve with something like this? This was 2003. So some of the first projects my students did were an automatic confession booth. As a Catholic, I'm perfectly allowed to show you this. If you analyze the act of confessing, it's a very, very repetitive process. Basically, people have to enter into a place, they have to lock the door, they have to kneel down, they have to say a bunch of stuff that nobody really is going to listen to, and then they're going to get punished in a way, and they will just leave. So we could just simulate everything with a very simple state machine that was just playing different sound loops, inviting people to close the door, kneel down, confess their sins, and after 3 minutes would tell them, okay, your time is over, it's better if you leave. And we made it so well that people really believed that there was somebody hidden in this box. And you can see this is a very, very small cabin. It's like, barely the person could fit kneeling down. Some other machines that we built was, for example, a machine to allow you socializing when you go out drinking. Again, you have to put this in context. This is design students trying to learn about digital technology, so I try to give them pretty broad design tasks. In this case, my students came with the idea that when you go out and socialize in Sweden, you don't really start talking until you have been drinking enough. So they thought, okay, this could be extended. There are some people you only want to meet when you've been drinking enough. So they had the idea of hacking the telephone contact list in your Sony Ericsson T610, which is one of the most sold phones ever by Ericsson, so that you could only access some people when you had been drinking enough. So we built a breathalyzer that was hooked into this phone, so when you had enough alcohol in blood, it will let you access those people. And the more alcohol you had in your blood, as the level was rising, the list was decreasing slowly because you didn't want to call your ex-wife. And after a while, you could only call a taxi of your own trust because you might make a mess in the taxi. Well, we tried to sell this to Sony Ericsson because Sony Ericsson's design offices were just 20 minutes away from our office at the university with absolutely no success. But things like this led us to understand that there was a need to build a prototyping platform that people with absolutely no knowledge in technology could start using in just 5 minutes. The idea was you should go from zero to hero in no time. You should be able of building things and learning how digital technology works by spending as little money as possible. And this is actually the success of the Arduino platform. This is an open source project that started exactly 10 years ago in a basement in Italy. And since then, we built a community of believers. So we build a community of people that like to learn about technology in a bit of a different way. And it ranges from 5 years to 99 years of age. And they come from all over the world. This is a graph that shows the different continents and where the audience arriving to our website is coming from. Yellow represents Europe, green represents North America, and the other colors represent the other continents. I computed these graphs plus some others because for 6 years in the project I was basically running the web services. I became a father, and more or less like you. I was sitting home and I was running the website for the project. This is one of the advantages of running an open source project. You can do it from everywhere. So this was the first board we designed. And in 2005, there were still computers having a serial port. So we came with the idea, we need to build a system that can be as inexpensive as possible so anybody could use it to start working with electronics. And this design, if you look at it carefully, you will realize that, for example, all the resistors that have the same value are grouped together. So I put together the circuit board, this is actually my design, to make sure that people that didn't know how to solder wouldn't make mistakes while they were building their boards. It was probably not the most correct thing electrically speaking, but it was definitely the most correct thing from an educational standpoint. But very soon we realized that we were running out of computers with serial ports. Actually, most of our students at design and art schools, they work with Macintosh computers that never had a serial port. So we jumped into designing a board with a USB port. And when we added that surface-mounted component up there, which is basically a USB to serial converter, we understood that it was going to be a hell of a problem to let our students solder the boards, because if they had never soldered before, soldering a surface-mounted component was a bit challenging. So we asked a manufacturer how much it would cost to put on a pick-and-place machine and mount that piece for us. And he said, you know, turning the pick-and-place machine on is so expensive that I can put all the passive components and actually give those to you for free, you know, if you want to add that chip with the machine. And I said, okay, let's do it like that. And then we ended up selling 1.5 million of this, which is a completely fully mounted prototyping platform that cost only 250 Swedish crowns. And this was the key aspect. The key aspect was we made something where the price was so low that it didn't matter for somebody I didn't know to take the risk to buy it, to get started trying with technology. That was the key. Well, since then, there have been literally hundreds of boards. This is just small teaser from my personal collection of circuit boards. I think I have over 250 boards myself. And there is boards made by us, there is boards made by other people, there is clones, there is derivative designs, there is boards that can address a lot more pins at our boards, boards that run on 32-bit cores, boards that run on 8-bit cores, etc., etc., etc. So there's really a huge amount of boards in the world. And the way we build these boards is by actually asking the community. We are strongly engaged in a conversation with the users that want to use these things. So we apply open source software techniques to open source hardware techniques. As a matter of fact, we were some of the builders of the open source hardware licenses, because until the moment we started, there were no proper open source hardware projects that were facing any challenges, like trying to address thousands or tens of thousands or even millions of people with open source hardware designs. But in the end, what we try to do is actually not to design hardware, and this is a huge misunderstanding. People look at Arduino and they think this company is only making hardware circuit boards, basically. But what we do is try to achieve very complex design scenarios where you want to integrate a lot of parts, like you want to add sensors to a mobile phone. This is, for example, an experiment that I designed for the people at SIX, the Swedish Institute for Computer Science, to prototype using mobile phones and hardware